approximately 3. So, my name is Matt Parker. It's very nice to meet you all. Thank you for your patience and your support throughout the day. We're going to run the Dominoes computer in a moment. First of all, I want to explain what on earth we're doing. Then I'm going to tell you what the calculation is the computer's going to do, and then I'll explain how it works, and possibly more importantly, how you will know if it's correct. So we'll say, first of all, it is amazing that we've had the opportunity to do this. I was asked a year ago to be the science communicator in residence at this year's Manchester Science Festival, and then they asked, do you have any projects you would like to do as part of the festival? And I said, yes. We're going to need 10,000 dominoes and a lot of space. And so this is a computer. I cannot overemphasize the fact that this works the same way your computer at home, or your phone, or your laptop, or your iPad. The circuits are a lot smaller in your phone and everything else, but it's exactly the same as this. And I was incredibly pleased to be able to do it here, because just behind the crowd of a bit oxygen group with a lose your spot is a research from the Manchester-based computer, which is the first proper electronic source memory for a global computer in the world. And it was made here in Manchester. Alan Turing was the operating system for it, and this is Alan Turing's centenary year, and so it was amazing to build a computer in Manchester. And I'm incredibly grateful. So for everyone here who's in the science industry, and everyone at the science industry, we give them a huge round of applause for making this possible. Let's get going. So, okay, here's what we're going to do. This is a calculator. This circuit adds numbers together. It takes two numbers as an input and gives you an output. It's like getting a calculator and saying a number plus another number equals, and the answer comes up on the screen. So the microphone is comes up. So we built this circuit so it could add any two numbers. We want to build it together. We want to build it. Check, check, hey! I will hold it here. We want to do is take any input, and so to work out what the calculation is going to be, we have, unsurprisingly, dominoes. So on each of these dominoes, if we pull one out at random, so this one here has a 6 and a 7, we would do 6 plus 7. If we pull out this one, we'll do 5 plus 12. I hope it's not this one. If we pull out, we will pull out a domino. It really hasn't come back, has it? Oh, it claims to be working. Yeah. Hello. Hey! Still working. Okay, here we go. So we're going to pull a random domino out of this tin. We're going to add those numbers together to get the output. Is there anyone here whose birthday? Here's a kid. Who's a kid's birthday today? Where? Everyone's pointing to the over here? No? They're hiding? That's fine. Hey, congratulations. Happy birthday. Would you mind picking a domino at random? So you can come up and pull one out. Okay. Okay, pull out. Okay, so you'll pick 9 plus 3. So, you're now got people starting to move. We're going to enter 9 and 3 into this calculator so we can add it together. The way this works, is, over here, oh, am I being careful? Over here are the unit columns. And we're going in binary. We have units, 2s, 4s, and 8. So for example, the first number was 9. To enter 9, we need an 8 and a 1. An 8 and a unit, because 8 plus 1 is 9. So in this case, we'll fill in the 8 units and we'll fill in the 1 unit over here to end with 9. The other number was 3. So to enter 3, we have that's completely unrelated. To put in 3, we need that is completely related. To put in a 3, we need a 2 and a unit, because this one is 3. So these guys are going to fill in that one, to the unit, that one, and that one over there. So I am going to get out of the way while I have them. The answer, if you do 9 plus 3, the answer is 12. So we want 12 to be the answer over here. And this is like the screen, this is the readout. There's unit 2, 4, 8, 16. To get 12, we need 4. We need 4 plus 8. So over here, the units should not move. The 2s should not move. The 4s should fall over. The 8s should fall over. The 16s should not move. That will be 12. If anything else happens, this is gone horribly wrong. These are chance it will go horribly wrong. That can go wrong. If you're the sort of person who likes to look for things that can go wrong, you will see a lot of junctions. When a signal goes into a junction, into one of these loops here, it should go in only one way. It shouldn't feed back the other way. Feed back the other way, everything has gone wrong. If you want to track back and see if everything's working correct, I can give you a hint at the beginning of the calculation. The very first step of doing is 1 plus 1. The answer is 2, unsurprisingly. I'll let you guys get out without me getting in your way. So 1 plus 1 is 2. So what should happen is the 2 signals should come in and they should stop there. They should not carry on to the unit column of the answer. They should stop. But the carry should. It should come all the way through, and this one should go into the next step, which is this one, that one. Nothing should come out, the carry will go on. That one will come out, that one will come out, that one will not. We will see how we go. If you really, really want to be looking for something exciting, when we get to the 4 should fall over. Oh, look at the 8 should fall over and the 16 shouldn't. So for that to happen, at the very end, the last thing that will happen is, we do not want this one here on the side to get through. So this one will try and stop it. So if you want to watch at the very end, this one will come in first and go that way and stop this one getting out. If this one doesn't come in and stop it and it gets out, we're going to get the wrong answer. So this will be the last bit that could go horribly wrong. Alright, are we all set up? Okay, here we go. Now, right before we run it, this whole thing would not be possible without all the people who are wearing our Domino building t-shirts. I've had an army of people help me design the circuit. They've gone and helped us refine it, and there are so many practical considerations to make this work, and they've worked tirelessly to do that. Could you give all the volunteers a huge round of applause? Now, we ran this yesterday on a smaller calculation, and I got a picture over here. She's project managed the whole thing to make sure it happens, to set it off, it works. Today, Sean over here, Sean designed the junction that you see with the one line on the side. It's called the junction. So that, she tirelessly on the living room table tested it tens of times. To make sure it works, it's reliable, and she helped all the designing team put it together, and today she's been organising all the time. Sean, would you mind setting off the on button? The on button is that domino there. Right, so don't touch again. We're going to give her a countdown, right? We're going to count down and we're going to set the countdown going. We're going to count down from 3 to 1 and we're going to say go. We're going to count down, of course, in binary. In case you were wondering how that works, you go. We're going to test one. It's not the real one. Charles is not the real one. We go 1, 1, 1, 0, 1, go. So it's 1, 1, 1, 0, 1, go. Right, that's 3, 2, 1 in binary. Okay, here we go. This is for real. Cameras are real rolling. Okay, you ready? Okay, here we go. Ready? 1-1. 1-0. 1. So far it's working. That should not have fallen over, and I know why it did. I'll mention in a second. In theory, I really want the ball to fall over. Yes, ball. Now this should give us the 8, but not the 16. Here we go. So it's going to go through the first junction. It's going to come through, and it's going to stop the other one. Stop it. Stop. So it comes to come out now. You may have noticed that 9 plus 3 is not 30. What happens is, here, this one comes in and stops this one from getting out. I was watching it very closely. They got there just pretty much at the same time, and it just managed to get through. And I think the same thing happened over there. So unfortunately, the 2s and the 16s snuck through. It's okay, I would be able to hold it together, but we were so incredibly close. But we did get the correct answer, we just also got an incorrect answer as well. I'm happy with that. Thank you all.